Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 4 Additional Mathematics Chapter 8 Vectors HOTS question example 2. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. In the following diagram, vector AB is equals to 2x and vector AD is equals to 3y. ABC is a straight line such that AC is equals to 4AB. Point T lies on BD such that BD is equals to 3BT. Point S lies on DC such that CD is equals to 3SD. Okay, for the question part A, find in terms of component X and component Y. Okay, in this case, for the part 1, they ask us to find the vector AS. For the part B, they ask us to find the vector DC. Okay, continue to read the question part B. Determine whether the points A, T and S are collinear or not. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Before we move on to the discussion of the question A part 1 followed by the part 2, okay, so what I'm going to do now is I'm going to underline some of the key information and the vectors that you are required to solve, okay, which in this case is vector AS and vector TC. So please hold on for a moment. Okay, so I have already underlined some of the key information and the vectors that we are going to find. In this case is the vector AS and vector TC. Okay, for now we're going to solve the question A part 1, which is vector AS. Okay, so now what you're going to do is, since we are required to find the vector AS, so the vector CD side is very important in this case. But before moving on into the vector CD, okay, we need to know the vector AC first. Okay, but we only know the vector AB. So how to find the vector AC here? Okay, take a look at the first information here. Given that AC is equals to 4AB, so we're going to use this information in order to calculate our vector AC. Okay, let us proceed to solve. Okay, so from here, given that vector AC is equals to 4 times with vector AB. Okay, so from here, continue our working. So vector AC equals to 4 times with 2x. Okay, so since the vector AB is 2x, so you include the value here. So 4 times with 2x, so from here you should get your vector AC is equals to 8x. Okay, so let me underline this. So now what I'm going to do is I'm going to include this 8x into the diagram here. So let me write over here the 8x. Okay, and then the next value that we are going to find is the value of BC itself. Okay, since we have already find the overall value of the vector AC, it is important for us to find the value of BC, I mean the vector value of BC. Okay, why am I saying so? Because the vector BC will be useful for us to solve the upcoming question, which is the question A part 2. Okay, so from here, so how to find the BC, vector BC? Very simple, guys. Vector AC you minus with the vector AB. Okay, so let me write the full form over here. So to find the vector BC will be equals to vector AC you minus with vector AB. Okay, let me box this. So from here, to find the vector BC will be equals to, okay, vector AC we have already find, which is 8x. Okay, and then vector AB we have already given in the question, which is 2x. So 8x you minus with 2x. So from here you should get your vector BC is equals to 6x. Okay, so this 6x I'm going to underline, and then later on I'm going to include in the diagram as well. Okay, so let me underline this. Okay, so in order to prevent confusion, what I'm going to do is I'm going to pull a line, okay, and mention here 6x. Okay, so I hope it is clear now. So once you have already find all the relevant information, okay, now we can proceed to find for the vector AS. Okay, so to find the vector AS, the first step what you're going to do is we can proceed to find the vector CD first. Okay, so let me write the working here. So step 1, find vector CD. Okay, so from here, how to find the vector CD? So we're going to use the law of addition, where we're going to use the vector CA plus with AD. Okay, so let me include in the working here. So vector CD is equals to vector CA plus with vector AD. Okay, in the question we have already find that vector AC is 8x, but then we are required to find vector CA, which is the opposite direction. Okay, so in this case your vector CA will be negative 8x. Okay, why negative 8x? Because it is the opposite direction of vector AC. Okay guys, I hope you guys are clear about this. Okay, so from here vector CD will be equals to negative 8x. Okay, and then you plus with the vector AD. Okay, in this case vector AD is 3y. Okay, so from here you get the vector CD is equals to negative 8x plus with 3y. Okay, this will be your first step. So let me underline the vector CD. Okay, so once you have already find the vector CD, so the next step what we can do is we can now proceed to find the vector SD. Okay, so how are we going to do that? We can use this relationship where CD is equals to 3SD. Okay, I hope you guys are clear about this. So let me write down the working here. So step 2, find vector SD. Okay, so let me write down the relationship as well. So given that CD is equals to 3SD, okay, CD we have already found in the first step, which is negative 8x plus with 3y. So you substitute the vector value over here. So from here negative 8x plus with 3y is equals to 3SD. Okay, so to find the vector SD, what you do, so this vector you divide with 3. So from here you should get vector SD is equals to negative 8 over 3x plus with y. Okay, so let me underline the vector SD now. Okay, we have already find the vector CD and vector SD. Okay, so from here now we can proceed to find the vector AS, since we already have vector SD and vector AD. Okay, so vector AS can be found using the law of addition, where you can add vector AD plus with vector DS. Okay, since we have already find SD, so to find DS, what you can do is you can just add a negative sign in front of the vector SD, which is in this case is the opposite direction of vector SD. Okay, it is understood guys. Okay, so from here we can proceed to our third step. Step 3, find vector AS. Okay, so to find vector AS, so we're going to use the law of addition, okay, where we're going to add the vector AD plus with vector DS. Okay, in the step 2, like I said, we find SD, but then now we are required to find the DS. Okay, so DS is the opposite direction of SD, so you just times the whole vector by negative for the vector SD, guys. Okay, it is understood. Okay, so to find the vector AS, so from here vector AD, so it is 3y. Okay, and then you plus with 8 over 3x, and then you minus with y. Okay, so you calculate this, you should get your vector AS is equals to 8 over 3 x plus with 2y. Okay, so this is the answer for the question A, part 1. Okay, let me underline the solution. Okay, so from here we will proceed our discussion for the question A, part 2, where we are required to find the vector TC now. Okay, so if you are wondering where is the vector TC, so this is the vector TC over here. Okay, so in order to find the vector TC, so the first step what you're going to do is we're going to find the vector BD over here. Okay, so why vector BD? So once you find the vector BD, you can use the relationship where BD is equals to 3BT, and from there you find the vector BT, and once you find the vector BT, you should be able to find the vector TC. Okay, so that is the overall idea on how you're going to solve for the question A, part 2. Okay, so if you still not clear, no worries, I'm going to do the working now, so just follow up with me, guys. Okay, so proceed with the part 2. So the step 1, we find the vector BD. Okay, so to find the vector BD, so we're going to add the two vectors, consists of the vector BA plus with vector AD. Okay, so from here vector BD will be equals to, okay, so from here vector AB is 2x, so from here vector BA will be the opposite direction of vector AB, which in this case is negative 2x. Okay, and then you plus with the vector AD, in this case is 3y. Okay, so this will be your step 1. Okay, let me underline this. Okay, so once you find the vector BD, now you can proceed to find the vector BT. Okay, let me write down the working here. So step 2, find vector BT. Okay, so in the question they already given that the relationship between BD and BT is BD is equals to 3 times of vector BT. Okay, I mean BD is equals to 3BT. We can literally use it for vector. Okay, so in this case we're going to apply the relationship over here. So vector BD is equals to 3 times vector BT. Okay, so from here vector BD we can just substitute the value that we have obtained in the step 1 over here. So from here negative 2x plus with 3y is equals to 3 vector BT. Okay, to find the vector BT, what you do, you divide this BD, vector BD by 3. So from here you should get vector BT is equals to negative 2 over 3 x plus with y. Okay, so this is your second step. So let me underline the vector bt. Okay, so once you've already find vector bt, now we can use the vector bt to find the vector tc. Okay, so from here, let us write down the working here. So step 3, so we're going to find vector tc. Okay, so from here, how to find vector tc? So we're going to use the addition of two vectors. Okay, in this case is vector tb plus with vector bc. Okay, we have already find vector bt over here, but then over here it is mentioned vector tb. So how to find the vector tb is very simple, guys. Tb is actually the opposite of vector bt. Okay, so from here, to find your vector tc will be equals to 2 over 3 x, okay, and then you minus with y. Okay, I hope now you should know why I find the vector bc in our very first step. Okay, like I said, we are going to use this vector bc to solve the question A part 2. Okay, so by the way, this is your vector bc over here, which in this case is 6x. Okay, you plus all of the values. So from here you should get the vector tc is equals to 20 over 3x minus with y. Okay, so this is the answer for the question A part 2. Okay, let me underline the solution. Okay, so let us proceed our discussion for the question part B now. Question part B, we are required to determine whether the points A, T and S are collinear or not. Okay, if you are wondering where is the point A, T and S, so this is the point A, T and S. So we need to determine whether they are collinear or not. Okay, collinear means that point A, point T and point S should be within a same line. Okay, that is the meaning of collinear. But of course in this diagram it looks like in a straight line, but you can't just simply assume it is collinear. You need to support with the mathematical statement. Okay, so in order to determine whether it is collinear or not, okay, we have already find the vector AS. However, we need at least one more vector to support. Okay, you can use either vector AT or you can use vector TS. Okay, and then you form a relationship between vector AS and vector AT or TS. Okay, to form the relationship, and then you from there you check whether they are collinear or not. Okay, that will be our calculation. Okay, to determine whether these 3 points are collinear or not. Okay, so enough with our discussion. So let us begin our working for the question part B. Okay, so for the step 1, what we're going to do is we're going to find the vector AT. Okay, so from here, to find the vector AT, we're going to use the addition of two vectors between vector AB plus with vector BT. Okay, so from here you should get your vector AT, okay, is equals to, so from here vector AB is 2x. Okay, and then you plus with vector BT. Vector BT, okay, we've already find in the working of the question A part 2. Okay, you just include this value over here. So from here, negative 2 over 3x plus with y. Okay, close bracket. So from here you calculate all, you should get your vector AT is equals to 4 over 3 x plus with y. Okay, so let me underline this. Okay, so like I said in the earlier of discussion, okay, you need to use either vector AT or vector TS to check whether the point ATS are collinear or not. Okay, so from here, so let me write, okay, you can form this relationship where vector AS is equals to K AT or vector AS is equals to K vector TS. Okay, either one it is acceptable, guys, but since in this working we have find the vector AT, okay, so we use this relationship. Okay, then you can ask me, so why don't we find the vector TS? It is up to you. You can find vector TS and then you form the relationship, and from here you check whether the 3 points A, T, S are collinear or not. Okay, so by the way, I'm just showing this just for your explanation, guys. Okay, let me remove this. Now you're only going to focus on this relationship. Okay, so the concept is pretty similar to the finding the parallel vector. Okay, if you manage to form a scalar multiple, that means the 3 points are collinear. Okay, so from here to find the scalar multiple K, so what you do, the vector AS you divide with vector AT. Okay, so from here let us continue our working. So let us include the vector AS. So from here vector AS is 8 over 3x, okay, and then plus with 2y, okay, and then you divide with, okay, let me underline the fraction, 4 over 3x plus with y. Okay, so as you can see see here, the numerator you can factor out the 2 so that the 4 over 3x plus y and 4 over 3x plus y can be cancelled off. As you can notice here, there is a relationship between the numerator and the denominator. Okay, so from here what you're going to do is, so the numerator we're going to factor out the 2. Okay, you factor out the 2, so you're left with 4 over 3x plus with y. Okay, so the denominator, since there is no change, so we're going to copy paste this. Okay, so now what you can do, you can just simplify this, cancel this, cancel this. Okay, so from here you should get your K value is equals to 2. Okay, let me underline this. Okay, so from here you get the relationship between vector AS and vector AT is vector AS is equals to 2 vector AT. Okay, so let me box this. So since you managed to find a scalar multiple value, okay, so now we can conclude that point A, S and T are collinear. Okay, so we have already supported the statement with this mathematical statement. Okay, so let me write down the full statement over here. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give it a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, feedbacks or questions, feel free to put down in the comment section. Thank you everyone for your support, and I'll see you in the next video.